Hello everyone, my name is Rashmi Shivanadhuni, working as an assistant professor in Mlritm of CSM department. So today I have chosen the topic Perceptron Networks, which comes under the soft computing subject. Firstly, we need to know what is meant by perceptron. So here comes the perceptron is the simplest form of the neural network that going to take the decisions by combining the inputs and the weights with applying of the activation function. So mainly it is used in the classification problems, and also the perceptron is going to build with the block of many deep learning models. So firstly it is going to take in the form of like it takes multiple inputs and it is going to assign some weights for the inputs. Later on it computes or it weighted the sum and applies the threshold function. From the threshold function we need to like we are getting the output which is either 0 or 1, nothing but the binary outcome. So it forms the foundation for of larger neural networks. So this is how the perceptron is. So if you look into the picture of the perceptron network, this picture gives the input weights x1, x2 and so on xn inputs, where for every weight for every input we're having the w1 weight, w2 weight and so on wn. Nothing but those weights are carried to the inputs. From there we are going to calculate the weighted sum with the summation, and with applying of activation function we are getting the output. So coming to the part of perceptron network, how it is going to handle. So firstly we have the inputs, nothing but x1, x2 and so on xn. So the inputs are the fundamental features, or we can say the measurable patterns or the attributes of the data points that is going that the perceptron uses to make the decision part here. So each input involves or each input provides the signals that is going to contribute the final output. So for example we are taking for an OR gate, the inputs are binary, so x1 x2 which belongs to the 0 or 1. So if you are taking the 2 x1 x2 that belongs to the 0 or 1, nothing but only the binary inputs like in taking as an 2. So here the input themselves have no inherent influences, which nothing but unless the weight multiplied by the weights. So second one is the weights, that is nothing but w1 w2 and so on wn. So where it is going to determine how strongly each input contributes to the prediction. Here the larger weights means the corresponding input having the higher impact on this. So weights are learned, or the weights learned during the training part here to adjust or going to adjust based on the errors. So they act as the important scores for the each feature. So next one is a bias. So this is a bias is nothing but it's a constant value which is added to the weighted sum to shift the decision boundary here. So it is going to act as a complicant, or we can say, or it's an important part in the computation process. So it also allows the perceptron to classify correctly when all inputs or the features are 0. So biases are like it's going to ensure how the model is not forced to pass the decision boundary through the origin. Next one is a net input, nothing but the weighted sum. So as we said before, after taking the inputs are carried through the weights where we are going to calculate the weighted sum. So the weighted sum is nothing but the combining of all the inputs and their weights. So wi xi plus b. So wi is nothing but we're going to call as an weights, xi is nothing but the inputs where it is going to carry with the bias which is the constant value. So here it is going to represent the activation through activation strength before passing through the activation function. So what is meant by activation function? So it is also called as a step function. It is going to convert the numerical values into the binary output. Nothing but it is going to give, or it introduces a non-linearity in the decision making. So it is going under gives the decision is going to give in the linear part. So always the output is 0 or 1, which is nothing but making the predictions on basis of the binary classification. Nothing but it's going to take the suitable part of for the binary classification. Next one is the fundamentals of neural networks. So as we know already what is meant by neural network, where also we have certain layers also. The first one is the input layer, hidden layers, and the output layer. So how the perceptron is going to work through these layers? First of all, we have the input layer. So the input layer, as we know, it is going to take the inputs, or the input layer provides the network with the raw feature vector. So nothing but x is equal to x1, x2, and so on, x1, xn. So no computation happens here, nothing but the only values it is going to take. So this is nothing but the input layer. It is going to pass only the values, the input values, to the next layer, that is the hidden layer. So hidden layer, what is meant by hidden layer? Nothing but the hidden layer contains many or multiple perceptrons, or else we can call as neurons here, which is nothing but it is going to represent the data here. So where we have the weight matrix for the hidden layer and the bias vectors. If you look into the formula here, where it is going to have the combination, nothing but input is carried with the weights and the bias values. So W1, which is going to represent the matrix, weight matrix for the hidden layer, and the B is nothing but the bias vector. The non-linearity function, nothing but we are applying the functions or the activation functions for the carried inputs. So where we are using RE, LU, or sigmoid, we can say the tan H, etc. So it is going to take the more importance here to evaluate the non-linear function. So the hidden layers basically used for identifying the complex problems or the complex data where which not visible from the raw data. So adding more hidden layers, which is going to improve the model in the expensiveness. The third one is the output layer. So the output layer is nothing but after the input layer, hidden layer, this is the output layer, which is nothing but the third layer, the last layer. From the input layer, the inputs are carried to the hidden layers. The hidden layers are going to give to the output layer. So here comes the output layer gives a final prediction of the values which we carried from the input layer. So each where it is going to use a binary or the multi-class or the continuous values here. So if you look into the formula for the output, nothing but how we are computing the output layer. So if you look into the formula, so where we have weights with the activation functions and the biases, and also the activation, I can say the activation function depends the input, like the output activation function depends on the task. Like if you are taking the sigmoid, it is going to classify the binary. If you take the softmax, it is going to give the computation on the multi-class classification. If you take the linear part where the regression will get from this. So this is how we look into the layers. If we talk about how it is going to work, the perceptron network, how it is going to work. So training a perceptron means finding the suitable weights Wi and the biases B, such as most training parts are correctly classified. The first one is a compute and the weighted sum. So the first thing, the perceptron, it's going to calculate, the perceptron first calculates a weighted combination of the input features along with the bias. So this is a formula we have already. We discussed the Wi xi plus B, WI is nothing but weight, and the XI is the input values, and the B is the bias, which is a constant value. So taking these values, we are going to compute the weighted sum. The second step, apply the activation function, nothing but the step function. So here it is going to simplify, or it is a this perceptron uses a simple activation function to convert the numerical value to the binary uh, class label. So if the value is 1, the if we are getting the value 1 or 0, so it takes in the form of any activation function. Third one is a compare prediction with the actual output. Nothing but the perceptron checks if the predicted value matches with the true label. Nothing but we can say it is an error. So fourth one is update the weights. Nothing but taking of the learning rule. So whenever the perceptron misclassifies a sample, it is going to update the weight by the amount of proportional to the error and the input value here. So this is a method, or we can say this is the formula where we are using to uh, convert the values and also getting the proportional error. Fifth one is update the bias term. So this is nothing but if we are adjusting the bias, so the boundary, or we can say the decision boundary, can be the left or right here. So sixth one is repeat all samples across multiple epochs. So nothing but the perceptron cycles through the entire data set. It is going to cycle several times, nothing but epochs, unless the get the stable solution of that. The seventh one is the final learned model. So after training, the perceptron is going to give the prediction values, or it is going to produce some predictions using the step function here. So step of w power t x plus b. So this is how the perceptron is going to work. So as we learn what is meant by perceptron, so and also the layers, how it is going to work with the perceptron, the basic terms of the perceptron. So if we need to know what is meant by perceptron and also multi-layer perceptron, so we have some aspects here to differentiate between perceptron and also with the multi-layer. So if we talk about the first one, model depth. So coming to the perceptron, it is a single layer with no hidden neurons. Coming to the multi-layer, the name which says the multi-layer, where having the one or more hidden layers. The second aspect is the type of pattern learns. Here in the linear, nothing but the perceptron is having the it is going to learn only linear relationships with a straight line separation here. Coming to the multi-layer, it is going to learn the complex and also non-linear patterns, which is having the curved boundaries. So in linear or the perceptron, we have the linear relationship with the line. In the multi-layer perceptron, we are having it is going to take the more like complex and also curved part. The third one is the problem solving ability. So coming to perceptron, cannot solve the XORs or non-linear separable problem, because it is going to handle on the linear thing, linear relation. Nothing but it's going to calculate by using the or the AND methods. So coming to multi-layer perceptron, it's going to solve exactly the opposite of this, nothing but XORs, and also it easily solves a complex classification task here. Fourth one is the activation function. So in perceptron, it is going to use a simple step function, nothing but in 0 or 1 output you are going to get. Coming to the part of multi-layer perceptron, it is going to take the advanced activations, nothing but ReLU, sigmoid, and the tan H for super blending. Next one is a learning method, where the simple perceptron or the perceptron is going to train with the simple perceptron update rule here, where we are in multi-layer perceptron, it is going to tackle with the back propagation and the gradient descent. Coming to the uses, how the perceptron and the multiplayer perceptron are uses in the real world. If we take the perceptron here, it is going to have the simple demonstrations on basic classification. Coming to multi-layer, mostly it is used in AI systems like vision, NLP, and deep learning applications. So first of all, we need to know where it is going to use, nothing but the application part of the real world. The perceptron is going to use in many ways. I can say the first one is a binary classification, where it uses, it is going to give the simple decision yes or no, nothing but mostly it is used in the spam detection or basic quality checks. Second one is a logic gate modeling. So here it's going to implement in the gate separable gates like and or the NAND with perfect accuracy. Third one is a pattern recognition, nothing but it's going to identify the patterns where classes are separated with the straight lines, where I can say linear separable. So next one is a feature important inside, where the values are indicates with the feature and also having the influence on the output where strongly or the more strongly. Next one is an educational tool. Now, here it is most commonly used to teach the foundations of the machine learning and the neural networks. So till now we came to know what is member perceptron applications and all this. So this is a time to learn what basically it is going to used and where it is used and what is the advantage of the perceptron here. So the simple and the basic architecture it is going to use, nothing but we can learn or we can understand in an easy way, and it is going to implement and visualize as a basic neural model. The second advantage is a fast learning. So where it is going to take the lightweight computational, where in like it can be usable or compatible with the small devices. Third one is a works on linear separable data, which is going to have the, or we can say it is going to achieve the perfect performance when the straight line boundary exits here. And the next one advantage, low resource equipment. So here it is going to having only the minimal requirement like minimum memory for the computation, and also suitable only for the tiny data sets. The last advantage is the foundations for deep learning, where it is going to form the conceptual basis for the multi-layer perceptrons, and also it is going to uh, basic foundation for learning the complex patterns. So we have the advantages, and also we need to know the basic disadvantages of the perceptron network. So no linear learning, nothing but it fails on XOR values or the XOR problems, where it is having, or it's where it computed through the curved or the complex boundary. The next one is a binary output only, nothing but it's going to give only 0 or 1 values, but it cannot handle the multi-class or the probabilistic outcomes without any extensions. And also the third one is a no hidden layers, nothing but if you are using the hidden layers, the accuracy can be high, or else we can say we'll get the more accuracy output here. So in perceptron network we don't have any hidden layer, nothing but it's going to have the lack on the depth, and also it is it making the unable to learn the hierarchical and also um, abstract the patterns. The the fourth limitation or the fourth disadvantage is sensitive to data scale. Nothing but when performance drops, if features are not normalized or scaled properly. The last disadvantage, not suitable for real world ML machine learning. Nothing but it's so simplistic for modern tasks, nothing but vision and NLP or sequence modeling. So this is how the limitations of the perceptron network. So what is meant by perceptron, and how we differentiated the perceptron with the multi-layer perceptron, and also we came to know the basic idea of how it is going to train the data to using these many layers with the values, biases, weights, and all this, how we are computing activation functions, and also weighted sums here. Through this, the value can be of binary, nothing but 0 or 1, we can say. So this is how the perceptron networks is going to handle. So later on, the coming sessions, we need to know what is by multi-layer perceptron exactly. So thank you.